Greetings, mobile soldiers. Welcome to Room Mobica. This is mobilization, and for the last talk of the day, we will mix Android development and IoT. Android development is not only limited to smartphone apps. We will see today how we can build our own home automation device using Google services, writing some Android code. My name is Gautier, I'm French. My English is French too, sorry about that. And one day for my home, I wanted to buy smart light bulbs because those are beautiful and it looks so cool. So I went online and searched for some I could buy, like those Philips Hue light bulbs, which are really nice because you can change the color of your room by using your voice, talking to the Google Assistant, saying stuff like, hey Google, change the color of the room to blue. That looks fun. But when looking at the price, almost 200 euros, that's crazy. And then looking at my wallet, I realized those light bulbs are not for me at all. Because you know, I'm a developer. I'm not a professional footballer. I don't have that much money, especially for that. But you know what? It's actually not a problem because I'm a developer. I mean, we are developers. Laura said it very well a few hours ago. We are developers. We daily create useful products from scratch. We are creators. So why can't we try to recreate the same stuff like smart light bulbs, but using our own hands instead? So, and most especially with a very limited budget instead. That's possible. And to be able to create a very similar device, a very similar product, the first thing we have to do first is to understand how it works under the hood, how those expensive light bulbs work. From what I understand, when you say something like, hey Google, change the color of the rooms to blue, the Google Assistant uses machine learning and a lot of complicated stuff to understand what you say inside a context, and to understand what action should be done from what you said. And once the Google Assistant understood, hey Laura, you missed this slide. It's the best slide I think of the day. So, yeah. So yeah, when you say, hey Google, change the color of the room, the Google Assistant uses machine learning, understands what action should be done from what you said, and once it understood that, the Google Assistant will forward that action to a web service in the cloud. For instance, here, it will forward the action to Philips server, the light bulb manufacturers. So when you say, change the lights to blue, the Google Assistant will convert that sentence into some JSON data. For instance, for user 42, we need to execute the action blue, so the color will be blue for the device number 8. So change the lights to blue. The Google Assistant will convert that sentence into a JSON and will forward that JSON to the light bulb manufacturer, in that case, Philips servers. So it's a typical REST call from Google server to the light bulb manufacturers. So when the web service receives that JSON data, it should parse the JSON to understand what action should be done. And then the web service should try to find a way to contact a peripheral in your home, which will be responsible for controlling all the other devices in your home. So this is called a bridge. And that's the reason why when you buy some Philips Hue lights, they come with this device, which is a bridge. It's a bridge between the internet and devices in your home. And it's a bridge that's in a secure way. It's a secure bridge between internet and devices in your home. And this component is mandatory because its goal is to control local devices. And it is this one, Philips Hue bridge, is only compatible with Philips Hue light bulbs. So it's not very good because it's very proprietary. It only works with a limited range of devices from a given manufacturer. That's not so good because it looks like a proprietary black box. So anyway, so when you say change the lights to blue, the Google Assistant understands the sentence, transform it to a JSON data, forward that JSON data to the web server, to the light bulb manufacturer web server. The light bulb manufacturer finds a way to contact a local device in your home, and that local device will be responsible for controlling other devices in your home, such as light bulbs, in a secure way. So in your home, you really need a central device responsible for controlling all the other ones. And today, we will create a very similar device, but using a Raspberry Pi instead. And it will be much better because It's a free platform. We can program it the way we want, using the language we want. And we won't be limited with a very limited subset of devices, because since we can program it the way we want, it will work with whatever we want. So the Raspberry Pi will be able to communicate with Google to control your lights in your home. And on this Raspberry Pi, we need an operating system to control it. So I will install Android Things inside, which is a variant of Android optimized for embedded devices and the Internet of Things devices. You can install any operating system you want on the Raspberry Pi. You could install a Linux distribution or whatever you want. But you know, most of us are Android developers, and it's fun to like control a Raspberry Pi writing an Android application, and that's what we will do today, and it's the purpose of Android Things. To install Android Things onto a Raspberry Pi, it's very simple. You just download a binary image, and then you simply flash it to the Raspberry Pi, the same way you would flash any other distribution. And it usually takes around 20 minutes, and then you are done. You can flash Android to a Raspberry Pi in 20 minutes, and you have Android onto a Raspberry Pi. That's so cool. And you know, it's really cool because now Android is like everywhere, which is great because using the same knowledge, the same SDK, Android SDK, we can build apps for phones and tablets, watches, TVs, and cars. And now with Android Things, we are not limited to those types of devices anymore, because we can create with Android Things any kind of Android-powered objects. We can invent new devices and write some Android code to control those. And since it is Android under the hood, we can even build IoT devices using Kotlin, coroutines, writing some JUnit code, and Mockito to mock stuff. It's like the platform we have, Android, is very great to create applications, so why not use those same advanced tools to create even better IoT devices? And that's so cool, and it's really easy to get started. Once you have flashed Android Things onto the Raspberry Pi, so 20 minutes later, you have to create an application to control the Raspberry Pi. And the best way and the only way to create an application on Android, you know, I mean, you have other ways, but one of the best ways is to use the official IDE, which is Android Studio. So you will start the official IDE, and then you will select to create an Android Things device. So you know you have choice to create any kind of variants for Android, like usually you create apps for phones and tablets, but you can now also select to create an application for Android application for Android Things. And to deploy it, to deploy your Android application to the Raspberry Pi, it will be the same as you are usually used to. Means either you click on the green arrow on Android Studio to deploy it, or you can use ADB, Gradle, or whatever you like. This is an example of a project that I made with Android Things. It's a robot made of a shoebox, embedding the Google Assistant, so I can ask it to give me some chocolates. Give me a chocolate bar.
Here you are.
This robot, made of a shoebox, is running Android. That's so cool. And you know, I don't have any electronics background at all. I'm an Android developer. And it only took me like a weekend to build it with my Android knowledges. And so you can do the same in a few days too. So really, Android is everywhere now, from inside a shoebox to the International Space Station, because if you didn't know, some Android devices are in the International Space Stations. And when you think about that, like if Android can be into space, I mean, there's no reason why it could not be in your home, acting as a bridge between the Google Assistant and devices there. I mean, if it's safe enough for the International Space Station, I guess it's safe enough for your home, probably. So we will build a device very similar to the Philips Hue bridge, but using Android Things instead, because, and you know, it will be awesome because we are awesome. I mean, obviously we are developers. So let's start again from the beginning. Remember, when you say, OK, Google, change the lights to blue, the Google Assistant will call one of your web service. And to tell Google which web service it should call, it's quite simple. You have to create an Actions on Google project. Actions on Google is the way to create applications for the Google Assistant, whether it's a chatbot or a smart home application for home automation. So let's do it. First, we go to the Google Actions on Google Developer Console. we create a new project, and we select Smart Home App. If we wanted to create a chatbot using Dialogflow, we could click here. But today we are more about home automation, so we will select to create a Smart Home App. And remember, the Google Assistant should communicate with your web server in the cloud. And to tell Google which web service it should call, it's quite simple. It will, just after you create a project, it will ask you the URL of the server it should call. So to which URL it should forward the REST JSON data. And that's the reason why when you create an Actions on Google project, the first thing it will ask you is an URL. It's actually the URL of the web service it should call to forward data. And of course, only Google should be allowed to communicate with your web service, nobody else. It must be very, very secured. Otherwise, with a simple HTTP call, anybody could query your web service and turn off the lights in your home, which I guess is not something you want to do unless you're not in your home, and that could be good. But usually, you don't want other people to control devices in your home. So your web service has to be very, very secured. And to ensure that only Google is allowed to communicate with your web service, you have to specify, when you create an Actions on Google project, the address of an OS2 server. So that's very good because, you know, it's very, very standard, it's OS2. And that way, only Google, the Google Assistant will have a valid OS token, so only the Google Assistant will be able to communicate with your web server forwarding a valid OS2 token. So the only drawbacks you can see here is like, it's the same I had. It's the first time I created a project and I saw, come on, I have to create a OS2 server. I don't have time for that. And remember, you can find on GitHub a lot of projects and you can just clone an OS2 server and start in like 5 minutes. So it's actually not a problem to provide an OS2 token. You can find some implementations on GitHub. And if you are a company who wants to build an IoT product for the mass market, usually you are rich enough and creating an OS2 server will not be a problem for you. And once you have specified the address of your OS2 server, so you have two things to specify: the address of the web service it should call and the address of an OS2 server. And once those two things are specified, you can click on the test draft button just here. And now the Google Assistant will be able to contact your web service in a secure way when it needs to. And Actions on Google will actually communicate, will contact your web service for 3 different occasions, which is called actions here. So it will call your web service for 3 different occasions: when it needs to synchronize data, when it needs to execute an action, and when it needs to query the state of your devices. Let's see the first one. So the first time the Google Assistant will call your web service, it will be to do what's called a sync action, to synchronize data. That's very important because, you know, the Google Assistant is not aware of which devices you have in your home. It cannot infer that you have a smart light bulb or a smart dishwasher or whatever possible. The Google Assistant does not know about that. So the first time it will query your web service, it's with a sync action to know which devices you have in your home, which devices it can control using the user's voice. So the Google Assistant will first execute an HTTP post request, which will be very similar to this one. So it will be like a request ID, and you can see here the intent is sync. So basically what you have to do is, in your web service, when you receive some data, first you check if the OS2 token is valid. That's obvious. And then you just have to pass that JSON. And if the intent equals sync, you know that the Google Assistant needs to know which devices you have in your home. So here is an example of what you should answer, what your web service should answer when it has those data. So here you just have to answer that in your home you have an array of devices. Actually, you have only one device, which is a light device. It's a light bulb. The device you want, you have to specify some traits. Traits are some characteristics the device is capable of. For instance, when you have a light bulb, you may want to turn it on and off using your voice. Say, hey, turn on the lights, turn off the lights. If your device is compatible with those kinds of characteristics, you have to specify that your light implements the on-off trait, the on-off characteristic. But you know, some rich people also have light bulbs, where you can change the color. My lights in my home, you can only turn on and off. You cannot say change the lights to blue. But some people have devices, you can change the color. So when you specify that the device is compatible with this trait, it means that when you say change the light to whatever color, the Google Assistant will be aware that the device is compatible with changing the color, and then will be able to change the color. So you have to specify the type to give some context, like turn on blah blah blah. So it knows your device is a light device, so it's okay, turn on the lights. And you also need some characteristics, because all the lights are not equal. Humans too. So here I name it light bulbs because, you know, I have no imagination, but you can say, you can give some alias, like turn on the chainsaw, and it would turn on the light if you want your light bulb to be named chainsaw, which would be very stupid, but you can do it. With Google Assistant, Google Assistant is compatible with different types. So you can control some smart cameras, fridges, thermostats, even dishwashers and lights. You cannot invent a very new device that has some features. It has to, it's like an interface. It has to implement this kind of interface. So in our case, we have a light bulb, so it's like a light device. And I said we also have to specify the characteristics, because a light can have one or many characteristics. And again, you have a lot of different characteristics available. So you have on-off to turn on or off, but you also have run cycles for dishwashers, for instance. So you have to specify the type of device and characteristics. So when you say, OK, Google, turn on the light or brighten the lights, if you implement the brightness trait, brighten the light will work, and the Google Assistant will understand that it needs to brighten the light. So traits are very important to tell the Google Assistant which action can be executed. It cannot just infer it from the type of device. So the official documentation is very, very good. It contains everything you have to know to create a web service compatible with actions on Google. You know, you have to specify which type of devices you have and which characteristics are supported, and everything is listed here if you want more information. Okay, so when your web service receives a sync intent, it should return the list of devices in your home in a JSON object. So now the question is, how do you create a web service compatible with actions on Google? And actually, you can use any technology you want, as long as it supports HTTP request and JSON. So you can use Spring Boot, Node.js, whatever you like. Today, we will use Google Cloud Functions, mostly because it's a very simple way to build and deploy web services. So let's create a Cloud Function. A Cloud Function is like a function that runs in the cloud, and you write your Cloud Function using some JavaScript, using JavaScript language. So here, I will create a function. I named it HA for home automation, but you can name it the way you want. First, what I want to do, if my function is started, first I need to check if the OAuth token is valid or not, to know if it's Google who is contacting my web service, my Cloud Function, or if it's somebody else. And then you have to get the intent. So you have to pass the JSON data and get the intent. And after, it's a big if or a switch case. If the intent equals sync, it means the Google Assistant needs to know which devices you have in your home. In that case, you can just return the following JSON object you saw earlier, telling that you have in your home one light bulb that is a light device implementing those characteristics, and it is called light bulb. So here, it's the reason why I like Google Cloud Functions, because you can see here the whole Cloud Function. It took me like 20 minutes to create it. I just created a very small function that passes JSON and returns a JSON object. So we have created our Cloud Function, and we can deploy it with a very simple command line. So Google Cloud Functions, you deploy the function named HA, and you want this function to be called when it receives an HTTP request. So it's one line to create, to deploy to the cloud a single JavaScript file, and this JavaScript file will be a function that will be executed in the cloud each time it receives HTTP request. And that's why I really like Google Cloud Functions, because not only it's easy to create functions, but it's also easy to deploy them to the cloud. You can try it for free. And I actually never have to pay for Google Cloud Functions, but if you do more than 1 million of calls in the month, it's like 40 cents for each million of calls. So the pricing is fair. And if it's for your own purposes, you will never reach the quota limit because 1 million of calls a month is like a lot. And you can use it for free. So I really encourage you to try Google Cloud Functions. Okay, the Google Assistant is now able to send a sync action to your Google Cloud Function. So now we can try it to see if it works. For that, you can start the Google Home app in your phone. You will select Home Control. You will add a new device. And here you can see the Actions on Google test project you saw earlier. It will forward, it will redirect to the OS server so the Google Assistant can get a token. Then it will query your Google Cloud Function with the sync intent to know which devices you have in your home. Your Google Cloud Function responds that you have a light bulb. And now you have integrated your smart light bulb, which is actually currently only your Google Cloud Functions, to your Google Assistant device through the Home application. So now the Google Assistant is aware that you have a light bulb in your home. So if you say, OK, Google, turn on the lights, Actions on Google, this time will send an execute action, because turn on the light is like an execute a specific action. The first one, remember, it was to know that you have some devices in your home. When you basically receive an execute action, it means that Google Assistant wants you to execute a specific action to your local devices in your home. So it will be very similar. You receive a JSON data. This time you pass the intent, it's execute. So you know you have to execute an action. Actually, you have to execute an action on your light bulb device. And what you have to do is the characteristic on-off, actually, its on has to be true. So basically, what you have to do, your Cloud Function has to pass that JSON. And here you can understand that you basically have to turn on your light bulb. So you have to find a way from your Cloud Function to communicate with your Android device. And then you can just respond that, OK, you wanted me to turn on the lights. This request regarding this device, it's a success. So it means you have successfully turned on the light. So it's like a knowledge. And now you have successfully turned on the light bulb device. It's very simple JSON. And finally, the last action our web service has to understand from the Google Assistant is the query intent. Query is very useful when we ask the Google Assistant questions like what lights are on in the living room. The Google Assistant cannot infer that. So to be able to answer that question, what lights are on? Yeah, my light bulb is off. The Google Assistant, once again, will transform that sentence, what lights are on, into a JSON, will forward that JSON to your web service or your Cloud Function. Your Cloud Function has to pass intent, the intent property. Here, it's a query. So basically, the Google Assistant right now wants to know the state of your light bulb. So you will just have to answer when you receive a query action that, OK, for this request, you wanted me to know the state of my light bulb. My light bulb actually is off. So you just answer the state of your device. And again, you can see there is nothing difficult here. It's just simple JSON. The only difficulty is to understand and to know which JSON contract you have to respect, like which fields you should return. But there is no magic. It's like an interface or something like that. You just have to consult the official documentation, and it will give you some example. Or if you want, if you receive those kind of actions, you have to answer with an array, something like that. So really nothing difficult here. Just follow the official documentation to know which data you have to return. But again, it's JSON. Thanks to those three actions, sync, execute, and query, the Google Assistant is able to communicate with your Cloud Function to control devices in your home. So we have done the first part, which was to create or to host a web service to the cloud that uses JSON to communicate with Actions on Google. Now, when our Cloud Function receives an execute intent, it should forward that action to your Android device, to your Raspberry Pi, so that it can turn the lights on, for instance. And you know, an easy and secure way to notify an Android device from the cloud is to use Firebase, and especially Firebase Cloud Firestore, which is a real-time NoSQL database you can listen to and be notified when data changes. You could also do it using a Firebase Cloud Messaging, for instance, to send pushes. Today, we will use a Cloud Firestore. That's very cool. So we will create a Firebase project. So you go to the Firebase developer console, you create a new Firebase project. Then, if you are familiar with Firebase Cloud Messaging, you know that you have to download Google Services.json file. You have to import to your Android application, so it can know how to communicate with Firebase. So, and we will create a user for our Android Things bridge. And we will add, of course, some security rules to ensure that only our Android device is allowed to query the Firebase content. You don't want, again, like other devices, to modify your Firebase data store in real time, because if that happened, maybe people can just modify data from your Firestore, and it will turn on or turn off devices in your home. So again, security rules on Firebase are optional, but it's better to add some. And here it's just a read-only, so our Android device is only able to read to the Cloud Firestore. Now we can populate a database, creating a lightbulb document with two attributes: on, a Boolean representing whether the light bulb is on or off, and spectrum RGB, which is a field representing the color stored in an integer. And the idea here is to use Firebase to modify data from this document. So for instance, when you say turn on the lights, the Google Assistant forwards data to your Cloud function. Your Cloud function will modify the on value from false to true. And since you use Firebase, Firebase will be able to notify directly your Android Things device in your home in a secure way. And here is how it looks. So we have created with a Firestore a collection of users. We have one user which has some devices. It has only one light bulb, and the light bulb has two fields, on and the color. So when a Firebase document now is modified, the Android Things device should be notified automatically. So in our Android Things application, we will wrap Firebase into a live data. And when the live data is active, we authenticate with Firebase to be able to access data. And we listen for Firestore changes on this document. So each time a device has been modified in the Cloud Firestore, we can just use the live data to post the value to, for instance, an observer in another activity. So I use live data here to show you that you can use the architecture components on Android Things, because Android Things is just Android, but optimized for Internet of Things devices and embedded devices. But usually, whatever works with Android, you can use it too in Android Things. So you can use Kotlin, you can also use architecture components, you can use live data. But again, here I show you, I introduce you to live data, but it's not mandatory. If you prefer to use RX or coroutine channels or do it manually, you can also too. Okay, our Android Things device is now notified automatically when a Firestore data has been changed, thanks to Firebase. And now, in our Cloud function, when we receive an execute intent, which means when we need to execute an action, we will simply update the Firestore content from our Cloud function. And if you want to modify a Firestore database using Google Cloud Function, it's very easy. You first have to authenticate to Firebase. It's just some boilerplate, but it's always the same three lines of code to authenticate with Firebase. Then you get a reference to your document. So for instance, if I want to turn on my lights, I will, from my Cloud function, I will pass the JSON. I know it's an execute intent. I will get a reference to my lightbulb document into Firestore. I will set the on property to true, and I will set the color to blue, because it's easy to write in an integer. And thanks to Firebase, since a value has been modified from the Google Cloud function, Firebase will automatically notify our Android Things device. And as you can see, modifying Firebase data from a Cloud function is like 3 lines of code. It's very easy, and it's another reason why I like Cloud functions. So you may not be familiar with the API, but you can see that it looks simple, and it actually is. Okay, so when we say, OK, Google, turn on the lights, the Google Cloud function passes the execute action from actions on Google, and then updates data in Firestore. Firebase automatically notifies our Android Things device when data has been modified. And now in our Android Things device, we just have to find a way to turn on the lights, and that's all. Oh, I forgot. We still have no lights right now because you know, we didn't have we are poor and light bulbs are so expensive. But don't worry, you can actually buy some light bulbs for very. You can buy light bulbs, but not expensive ones. For instance, you can buy those Bluetooth light bulbs on Chinese websites that cost around less than $10. Those light bulbs are very good. The only drawback is that you have to use this very ugly Chinese application to control the light bulbs. And it's not something we want. We want our Android Things device to control the light bulbs. We don't want that crazy application to control it. But it's cheap, so we will buy it anyway. And what we have to do basically is we don't want to use that stupid Chinese application. So we will just reverse engineering Bluetooth low energy devices. So we'll do some slight reverse engineering to understand how to control those light bulbs using Bluetooth low energy. And you know, the easiest way to intercept data is to do a man in the middle, to capture Bluetooth packets that comes from the Chinese application to the light bulb. And the good news here is that your Android phone and Android in general is very useful for that because there is a developer option on your phone which is named Bluetooth HCI Snoop Log. So the name is very like crazy. I don't understand what it means, but it does exactly what we want to do, which means capturing Bluetooth packets that comes from the phone to devices. So we turn on that developer option and it will be cool. So we go to the developer option, we enable the Bluetooth HCI Snoop Log, and now we will use the Chinese application to control the lights. So we will change the lights to red, to green, blue, yellow, and white. And at that time when I pressed buttons, it has sent some Bluetooth packets to the light bulbs. And since we have enabled the developer option, we can just have a generated file which is usually here, but it depends on devices. It's a pcap format, so it's compatible with Wireshark. So you just pull the file from your Android application. You can open it with Wireshark, and you can see that some Bluetooth read commands were executed. So here it was like a Bluetooth command to the service FFE5, characteristic FFE9, I don't know what. And this was the value which was sent for red, for green, for yellow, for anyway, blue, yellow, white. Okay, so we have intercepted Bluetooth packets, and we saw that to change the color of the light bulb to blue, we had to send the following value, which is like 56, I don't know why, FF00000FA. For green, I can see it was this value, and for blue, it was that. And with a little reverse engineering and some mind work, you can see that it's actually sending the value 56, who cares why, then the X color code representing the value, and then OOFOAA. So now we have reversed engineering our Bluetooth light bulb device, and we know that if I want to change my light bulb to pink, I will have to contact this service, this characteristic, and I will have to send 56, pink is FFOOFF, and then OOFOAA. And we will try it. To try it, we can just send raw Bluetooth data using, for instance, the NRF Connect application. So here, from my Android device, I will select this characteristic, this service, and I will write 56, then the pink X color code, OOFOAA, I click on send, and I can see that my light bulb is now pink. So that's very cool because it means like we have, in like a few hours, we have understood how this Chinese device was working. And we don't need that Chinese application anymore. That's so cool. So we have reversed engineering the light bulb, and we can write a simple Android Things application now to convert first an int color to a compatible data array. So usually you take your color in an integer, you get the red, the green, the blue, you create a byte array, 56, red, green, blue, OOFOA. You have created a small Kotlin function to convert a color stored in an integer to a byte array compatible with the light bulb. And then you can write another method to send that byte array to your Chinese device, Chinese light bulb. And you know that what is cool is that it's Android Things. Android Things is Android. So what you basically, what can with Android, which is using the Bluetooth LE API, you can do the same on Android Things too. So to send data using Bluetooth low energy APIs, with Android, you usually have to get the service. Here it's service FFE5 characteristic. And then you call your function to convert the color to a byte array, and you set it to a specific characteristic. And in like 1, 2, 3, in 4 lines of code, you have used Bluetooth LE APIs from Android to change the color of your light bulbs inside your Raspberry Pi. Now, in our main activity, remember earlier we have created a live data to listen to Firestore changes and be notified wherever we want. So in our activity, we get a reference to our live data, we observe it, and every time we receive some data, if the data is for the light bulb, we will just call our Bluetooth LE method to send Bluetooth packets to our light bulb. So here we will try it with the Firebase Developer Console. In the Firebase Developer Console, you can modify fields in real time, and we want to know if the live data is working. So we will just alter some data from on false to true. We will click update, and it turns on the light bulb because Firebase is communicating with your Android application, and then you have a live data that observes from Firestore changes and sends data to the Bluetooth light bulb through Bluetooth LE APIs. Everything is in place. Now we can test the final result. Hey Google, turn on the light.
Sure, turning on the light bulb.
Okay Google, change the light to blue.
You got it, changing the light bulb to blue.
Hey Google, change the light to red.
You got it, changing the light bulb to red.
So again, when I will repeat the video, you will see when you say change the lights to red, the Google Assistant calls your Google Cloud function. Your Google Cloud function will modify Firebase data store, and you will see that the value will be modified here in real time. Firebase notifies automatically your Android Things device. Android Things observe from Firestore and then communicates with your light bulb. Hey Google, turn on the light. You can see here it will change.
Sure, turning on the light bulb.
So that's very cool. Okay Google, the Firebase Developer Console to debug. And you don't need a Google Home device to communicate with local devices in your home. You can use the Google Assistant inside your phone and write turn on the lights using your keyboard if you don't have a Google Home device. And since all the understanding, like turn on the light, all the understanding of the human language to JSON data is made by Google, it means that it supports natively different languages such as Japanese. Trust me, I don't speak Japanese, but it seems to work. So unfortunately, there is no Polish support yet, but more language are coming soon. So I hope it will be available. Otherwise, you can use English, which is I'm doing the same actually, and it's working. And I think we are done. Oh wait, our bridge is running Android things, right? And we are developers, so we can control other devices for free now that everything is in place. For instance, this very nice light 3D lamp, I would like to make it compatible with the Google Assistant. And right now it's a little hot, so I would like to have a fan compatible with the Google Assistant. I would like to control my fan from anywhere using my phone and say turn on the fan. Basically, we can hack all those devices we have in your home. So remember, we have created everything. So to make a fan compatible with our home automation device, we just have to create a Firebase document. So we have created a light bulb. Now we can create a fan, which will be on or off, and a 3D lamp. To control the fan from Android things, what you could do is cut the wire, connect it to a relay module to turn it on and off programmatically. That's called electronic. That's very scary. But you can do it. And then you can just use Android things GPIO APIs, which are APIs. You know, the Raspberry Pi has a lot of pins you can connect devices to. And Android things has a lot of APIs to communicate with those devices. So for instance, to communicate with this GPIO relay module. But you know, communicating with electricity, cutting wires, that's so scary. And we are Android engineers, we are not electronic, and we care for our lives. So we will forget about the relay module cutting wires, and we will use some radio-controlled power outlets instead. Those work very the same. They use radio-controlled remote to, and with a remote using radio-controlled calls, you can just turn on or off some plugs, and it's safe because you just buy it and it works. It's very similar to, you know, earlier what we did is to understand Bluetooth packets, we did a man in the middle. So why can't we man in the middle radio communication? I mean, it's the same. So you can just buy an Arduino for $3 and a receiver to receive radio frequencies and an emitter to emit some. You connect the receiver to an Arduino. If you don't know how, just search on the internet, everything is written to tell you how to do it. And you have some Android, you know, when I press the remote button, I can see the code that was received by the Arduino. I didn't write that Arduino code because I'm not smart enough to write Arduino code, but the Arduino has a very huge community, and the very huge community has already created drivers for all the components you could ever imagine and are available on the internet. So what I did is I just bought the radio frequency emitter. I flashed my Arduino with code I found on the internet, and when I press the remote, it tells me which radio frequency was received, which radio frequency code. Now we can connect our Arduino to the Android Things board using GPIO wires, for instance, or directly using, you can connect your Arduino directly using USB if you prefer. And we will use Android Things UART API to communicate with the Arduino. So again, Android Things has a lot of methods to communicate with devices you plug here. UART is one of those. So I want to write the value 1. And in my Arduino, when I receive 1, it will send a radio frequency to turn on my fan. And when it receives 0, it will turn it off. And I had this 3D lamp, and I want to do the same with my 3D lamp. And for that, you can just, again, open it, connect a relay module, cut some wires. And with the relay module, it's very good because it can communicate and simulate a button pressed. A relay is basically opening or closing connection. So if you close and open, it's like pressing a button after all. So you can cut wires, plug an Arduino, but personally I don't want to. So I bought a 3D lamp using infrared control. And I mean infrared is like you can man in the middle it. I mean similar to everything. So what I did is I bought an Arduino, an infrared receiver. Again, I connect everything. I directly from my Arduino IDE have a sample project that gives me an infrared dump. When I press a button from my infrared remote, it gives me an infrared dump, which is scary, but I don't care, it works. So this is what the infrared dump looks like. And now, you know, very quickly, infrared is a short-range technology. If your Android Things device is very far away and you use infrared, maybe the Android device will not be able to receive the infrared call. So what you can do is you can buy this microcontroller. It's an ESP8266. It's very similar to an Arduino. You can program it the same way as you can program an Arduino, except that it has a Wi-Fi stack. It's very cheap. It's around $3 again on Chinese websites. And you can program it on an Arduino. It has a Wi-Fi stack. Since it has a Wi-Fi stack, this can host an HTTP server in your local Wi-Fi network. And so you connect an infrared red to the microcontroller. And then in your Android application, you can just use retrofit or OKHTTP to communicate with your microcontroller. And here is the final result, combining everything together.
Okay, Google, turn on the lamp.
You got it. Turning on the lamp.
Okay, Google, turn off the fan.
Sure. Turning off the fan.
Hey, Google, change the light bulb to blue.
Sure. Changing the light bulb to blue.
Okay, Google, turn off all the lights.
Sure. Turning off 2 lights.
Once again, turn on the lights. Google Assistant converts data to a JSON object that we communicate with your Cloud Function. Cloud Function modify Firebase. So it communicates directly with your Android Things device. To turn on the light bulb, it sends some Bluetooth packets. To turn on the fan, it communicates with USB to the Arduino. Arduino communicates with radio control to the power outlet. And turn on the 3D lamp. The Android Things device communicates using HTTP to a microcontroller that is very close to the infrared device. Basically, to sum up, Actions on Google works for smart homes, but you can actually transform any kind of devices you have in your home to make it compatible with the Google Assistant if you want. It's great for companies if you want to create a product compatible with the Google Assistant. So you will do exactly the same as what we saw today, but you can also hack some devices and make those compatible for your own needs too. So it's for companies and individuals. Android Things really simplifies building secure and advanced IoT devices. If I wanted to do that using a microcontroller like this, having an observable wrapper around the cloud Firestore to contact a light bulb using Bluetooth API, it would be like crazy using an Arduino. With Android, it's so easy. So that's a reason why Android Things is good for to build secure and advanced IoT devices. I really encourage you to give Android Things a try because you can really create your own devices, hack some. Android Things is really fun, so just give it a try. And it's really easier than it seems. Like to create that, it will require you only 2 days to create exactly the same as what you saw today. So the lecture was very fast today, but it was mostly to show you a preview of what you could do with Android for IoT devices, but also with Cloud Firestore and Google Cloud Functions. It was an overview of everything you could do, and now you have some ideas to create everything, to create even better things. If you want to know and to have more information about Android Things, there was a very cool talk last year at Mobilization, which was using Android Things to detect and exterminate reptilians, creating a smart flamethrower. That's really a nice talk I recommend. It's an introduction to Android Things if you want additional information. And if you want more information, everything is here. So the source code of all the projects you saw today, including the PCAPE Wireshark file, everything is committed here. So if you're curious and just want to know like how the cloud function was created or how was created the Arduino code, you just have to clone this repo and you will have the project of everything you saw today. If you want to do exactly the same as what you saw today at your own pace, which means creating a smart light bulb compatible with the Google Assistant, you can check this blog post, and it is written everything you saw today, so you can just read it and do it at your own pace. So it usually will take you 2 days or one weekend to do exactly the same. Additional information about documentation and how to reverse engineer Bluetooth devices and infrared devices if you're curious. And that's all for me. Feel free to follow me on Twitter. We will not have time for questions today. If you want a mug, you have 3, so first one, first served. Ask me on Twitter if you have any question. I will answer them very happily. Slides are available here if you want to read them at your own pace once again. And thanks a lot for your attention.